Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about further mechanic, paper 3, October-November 2024, paper 32. Let's take a look at the first question. A particle of mass 2 kg is attached to one end of a light elastic string of natural length 0.8 meter and modulus of elasticity 100 Newton. The other end of the string is attached to a fixed point O on a smooth horizontal surface. The particle is moving in a horizontal circle about O with the string taut and with constant angular speed of 5 radians per second. Find the extensions of the string. So the diagram should be a horizontal circular motion, something like that. Okay, it's moving in the horizontal circular motion. Okay, so you are having the radius over here. This R is actually the natural length plus some extension. So the R over here, the R over here is equals to the 0.8 plus X, that is the R. Okay. Then your tension, this is the R. So if you resolve the forces horizontally, then you have a tension is the centripetal force, mR omega square. And your tension will be following the Hooke's law. It will be lambda x over the A equals to the m square. The lambda is given as 100. Extension you do not know. The A is a 0.8. The m is a 2 kg. The r is a 0.8 plus x. And the angular speed omega is a 5. Okay. So now you just need to simplify them. Okay, I will multiply the 0.8 go to the right hand side. Okay, so I will get 40 times x 32 plus the 40x. Therefore, I found that my x is 32 divided by 60 or 8 divided by 15 meter. Done. That will be the answer for the question number 1. Okay, now we move on to question number 2. Now let's take a look at question number 2. A particle P of mass m is attached to one end of a light elastic string of natural length A and the modulus of elasticity 5 mg. The other end of the spring is attached to a fixed point O. The spring hangs vertically with P below O. The particle P is pulled down vertically and released from rest when the length of the spring is 3/2A. Find the distance of P below when P first comes to instantaneous rest. Okay, so this is a spring, not a string. So for spring, it will be something like this. Okay, so this is the natural length. And it has been pulled down until 3/2A. That means additional another half A over here. And when it released from rest, and the spring goes like this, goes up. Okay, so when it comes to here, the V is a 0. Okay, so the compressions, okay, my diagram need to draw clearer. Okay, so maybe when it reaches until a certain height, then it will become the V equal to 0. This will be the compression X. Okay, so this is the situations. This is the equilibrium, not equilibrium, natural length. Okay, so from these questions, obviously we need to use conservations of energy. You can see that the speed at the beginning and at the end, they are 0, so there will be no kinetic energy involved. So we will be using COE, conservation of energy. We have a GPE gain is equal to the EPE loss. Okay, so the formula for GPE is MGH. The EPE will be lambda over 2A of x2 square, x1 square minus x2 square. So what is your H? The H will be from 2A until x. So the H will be 2A, half A until x. So it will be half A plus x. So the lambda given as 5 mg here. The question given the lambda is 5 mg. The natural length is A. The extension at the very beginning, this is the x1. So the x1 is a half A. When it reaches until here, the compression is x square. Okay, so this is what we have. So from here, we can see that we can cancel the mg first. And I bring the denominator 2a go to the other side. I multiply the 2a go to the other side. I will get a plus 2ax. For the left hand side, I expand it. I get 5 over 4a squared minus a 5x squared. Okay, so we will be having a quadratic equations over here. I multiply everyone by 4. I get 4a plus 8ax equal to the 5. Oh, sorry, this is a square. Okay, so this is a 5a squared minus a 20. This one is 20x squared. So you have 20x squared plus the 8ax minus the a squared equal to 0. So we try to factorize it. You have a 2a here, a 2x over here. The a, and in order to get positive, you have you need to have a plus and minus. Yeah, you need to have this. Okay. So we will be having the a is equal to 1 over 10x and a is equal to the negative half x. So we know that the a cannot be negative. We will ignore it. Should get the answer x in terms of a. We shouldn't get the answer a in terms of x. So my answer over here, my x is 1 over 10a, or my x is a negative half a. So the x cannot be negative. We just ignore it. Okay. So the x over here is, that means now the x over here is actually 1 over 10a, but you need to measure the distance from O. Okay, the distance from O. This is the O. O is over here. So you need to measure the distance from O. So therefore, okay, the distance of B below O it will be equals to the A minus the 1 over 10A, and you get 9 over 10A. Just like that. Done. That will be the answer for the question number 2. Okay, so now we move on to the question number 3. Okay, now we take a look at question number 3. A diagram. Show two identical smooth uniform spheres A and B of equal radii and each of the mass m. The two spheres are moving on a smooth horizontal surface when they collide with a speed 2u. and 3u respectively. Immediately before the collisions, A directions of motions makes an angle theta with the line of center, and the B directions of motion is perpendicular to that A. Okay, so that means if you extend them, this will be perpendicular. Okay. After the collision, B move perpendicular to the line of center. After the collision, B will move perpendicular to the line of center. That is a V. The coefficient of restitution between the sphere is 1/3. Find the value of tangent theta. So I will redraw again the diagram. Beside, I will draw it before and after. So before, it will be 2, it will be the mass m moving down with the speed of 2u. The angle here is a theta. And as for the particle B, since this, if you extend this is a 90 degree, that means that this will be, theta. Okay, so the theta will be here. That is a 3u. The mass is a m. And after the collision, the question mentioned that the V goes perpendicular, VB. And the A, I will assume A is going this way with the angle alpha. Okay, so this is what I assume. Okay, so bear in your mind that this is the assumption. Then the VB already explained in the question that it's go perpendicular to the line of center. So VB confirmed, but it's just that VA, the angle, we do not confirm yet. So what we can do is that we will consider the directions of the radical light, okay, by using the principles of conservation of linear momentum, PCLM. So we are having m2u cos theta. I think I need to write below to get more space. So we have m2u cos theta plus the m of negative 3u sine theta is equals to the mVA cos alpha. The VB will be 0 because if you consider the directions that they collide, the VB goes perpendicular, so the VB will be not involved after the collision. So we cancel the M, then you get the VA cos alpha is the 2u cos theta minus the 3u sine theta. We call this one equation 1. Then if you consider the NEL, Newton experimental law, you get the E equal to the negative of the VA cos alpha minus the divided by the 2u cos theta plus the 3u sine theta. The question given you that the E is a 1/3, so we change the E become 1/3. This is a minus 0. So we will be having the VA cos alpha, VA alpha, yes, VA cos alpha is equals to the negative 2/3u cos theta minus the u sine theta. I call this one equation 2. So from the result that we have in the equation 1 and equation 2, we can see that the VA cos alpha are the same. So we can let 1 equal to 2. So if we let 1 equal to 2, then you will have a 2u cos theta minus a 3u sine theta is equal to the negative 2/3u cos theta minus the u sine theta. The u all cancel. Sine theta and cos theta, they all combine together. So this one is 8/3 cos theta is equals to the 2 sine theta. So you are having tangent theta is equal to 4/3. So the question are looking for tangent theta. then we are done. Okay, so this will be the answer for the question number A. Okay, number 3A. Now we move on. B. Find the loss of the KE as a result of the collision. To find the loss of the KE, we need to get the VA and the VB square. Okay, VA square and the VB square. So for the VA, if you involving the one that is perpendicular to the collisions, you have a VA sine alpha. Okay, if you consider the vertical motion, okay, before and after. So for the VA sine alpha, you are getting 2A sine theta. Sine theta. Oh, I think we need to deal with the theta first because we have found theta, tangent theta at part A. So we will be using the tangent theta just now. Tangent theta is 4/3. That will give you a small right angle triangle here. 4 here, 3 here, 5 here. Then from your equation 1, I have a VA cos alpha is equals to the 2u cos minus 3u sine. So it's a 2u of cos minus a 3u of sine. Okay, so by pressing the calculator, then you get 6 minus 12, you get negative 6/5u. Then if you consider the one that is perpendicular to the collisions, you have a VA sine alpha is equal to the 2u sine theta. 2u sine theta. So 2u sine theta, the sine theta we already know is 2u 4/5. Then you get 8/5u. Okay. So my VA square will be the negative 6/5u square plus the 8/5u square. Press the calculator, I get this one as a 4u square. Then as for my VB, if you consider the VB before and after, so VB will be equal to the 3u cos theta. VB will be equal to the 3u cos theta. So it will be 3u 3/5. 3u 3/5. And you'll get 9/5u. Okay, 9/5u. So your VB square, you don't need to put this anymore. So your KE loss will be the same as the KE initial, half m of the 2u square plus the 3u square, okay, minus a half of the m of the VA square plus the VB square. And if you take the half m out, okay, join them together, you get a 4u square plus 9u square minus the 4u square minus the 81/25u square. And simplify them, pressing the calculator, you get the answer as 72/25 mu square. That will be the KE loss. Okay, done. And now we move on. They want you to find in degree the angle through which the directions of motion A is deflected as the result of the collision. Okay, so you can see that over here is involving A only. So before, the A is moving like this with the angle theta here. Okay, this is the A. And after just now, my assumption was A moving with the angle alpha. This is a VA. This is my assumption. But from the working that we have over here, it shows that the VA cos alpha is negative. So negative means that the directions of A actually go reverse. Okay, the A actually is rebound after the collision. So A by right is supposed to be like this. Okay, then this is the alpha. This is the VA. This is the 2U. So just now from part A, we know that tangent theta is equal to 4/3. Whereas a calculator, we can get the answer as 53.1 degree. Okay, so from the result here and the result here, to get tangent alpha, you just take VA sine alpha divided by the VA cos alpha is equal to negative 6/5U divided by, 8/5U divided by 6/5. This one is 8/5U. This one is negative 6/5. So you get tangent alpha is equal to negative 4/3. Then you get alpha is negative 53.1 degree. So the meaning here is that at the directions of A is supposed to be going like this, but after the collision, it will rebound. Okay, after the collisions, it will rebound 53.1 degree. At the beginning, it's going 53.1 degree. So if without collision, the A is supposed to go like this. The A is supposed to go like this without collision. But after collision, the A rebound. So what is the angle of the deflections over here? So the angle of deflections is equal to 180 minus the 53.1 degree minus the 53.1 degree, and you get the answer as 73 points. 73 point, 180 minus 53.1 times 2. Okay, wait, 4/3 tangent. To be safe, we give 2 decimal places. Be more accurate, we give 2 decimal places. So this one, it will be like this, then times 2. So your answer will be 73.7 degree. That will be more accurate. Okay, so we don't round up the angle theta here and the tangent and the angle alpha here too early. We will need to leave the answer in 2 decimal places first before we rounded it up for the final answer into 1 decimal place. Okay, so this will be the answer for the question number 3. And moving on, we have question number 4. Okay. Okay, now we take a look at question number 4. The NA of a uniform rod AB of length 6A and the weight W is in contact with a rough vertical wall. So this is 6A, this one is W. Okay, so this is the center, this is the weight W. One end of an inline inaccessible string of length 3A is attached to the midpoint of C of the rod. The other end of the string is attached to a point D on the wall vertically above A. The rod is in equilibrium when the angle between the rod and the wall is theta, where tangent theta is 3/2. A particle of weight W is attached to the point E on the rod, where the distance of AE is equal to KA. K is between 3 to 6. The rod and the string are in a vertical plane perpendicular to the wall. The coefficient of friction between the rod and the wall is 1/3. The rod is about to slip down. So over here, the wall is about to slip down, means the frictional force will go up. And this is the normal contact force, RA. And this is the force W. This is the force T. And you can see that the length here and the length here are same. So which means that the triangle over here is a isosceles. So if it's an isosceles, then this will be a theta. So if this is a theta, then the angle over here will be 180 degree minus a 2 theta. Okay, so because later I need to resolve the forces vertically and horizontally. So it's important for me to know the angle here and the angle here. So this angle, it will be cut the 180 degree minus 2 theta into half. So if we cut them into half, then we have only 90 degree minus theta, which means that this will be a theta. So it will be more simple for me to consider this as a theta. Don't need to consider the 90 degree minus theta. It will be very more confusing. So this is the tension. Okay. So now I need to find the moment. Okay. The question wanted to find the value k. So to find the value k, there are two things you can do. You can resolve the forces horizontally and vertically. Okay, you can resolve the forces horizontally and vertically. Well, that's one thing you can do. Another one is to find the moment. So when we want to find the moment, usually we want to find the moment about A, because A itself have the frictional force and the normal contact force. It will be easier for us to handle if we find the moment at about A. Okay, so we can start with either one first, horizontally, vertically. So I will resolve the forces horizontally. Then I have the horizontally only involving this force and these two forces. So I have d sine theta is equals to the RA. Oh, by the way, the question giving you tangent theta is equals to the 3/2. With a small diagram over here, we will have 3 here, 2 here, and then this one, it will be 13. Okay, so we just write it down first. Maybe we can change it to become 3 13 T is equal to RA. Yeah, okay, we can do it like that. Then we resolve the forces vertically. Then you will have T cos theta plus the FA is equal to the W plus W. But they mentioned is the rod is about to slip down. That means your frictional force will be at the limiting equilibrium. So it will be mu R plus the mu RA equal to the 2W. So my cos theta over here is 2/13. My RA over here is 3/13. So from here, I can simplify this to become 3/13 T is equal to 2W. We're looking for the value K. So at the moment, maybe we can write this one as a 2/13/3W. I have equation number 1 here. Then we find the moment about the A. To find the moment about A, I will not using this T. I will use this D sine theta. And I will use this one D cos theta to find the moment. That will be easier for me. Okay. So if you want to find the moment about A, just focus on the A here. Then you can ignore the RA and FA. Okay, the RA and FA can be ignored. So there will be only T cos theta. T cos theta is over here. And the perpendicular distance to the point A, it will be 3A cos theta. Right? 3A BA, and then the distance 3a sine theta, sorry, 3a sine theta. Same thing go for the force of T sine theta. The perpendicular distance from A, it will be 3a cos theta. Then it's equals to the W of, for the W here, what is the perpendicular distance to the point A? It will be 3a sine theta. 3a sine theta. Then the one over here, the W over here, it will be Ka sine theta. So you can see that a sine theta can be cancelled off. A sine theta can be cancelled off. A sine theta can be cancelled off. Then you have the left hand side, you have 6 cos 60 cos theta is equals to the 3W. Okay. Then I have 60 cos theta according to the right angle triangle, 2 over 3. 2 over 13. Okay. Now maybe we can simplify that, become 12 over 13t. I call this one equation 2. And I put 1 into 2. If I put 1 into 2, then it will be 12 13t. 2 13 over 3. W is equal to the 3 plus K W. Cancel the W. This one can cancel. This one cancel. You get a 4. You get 8 equal to the 3 plus K, and then you get the K as a 5. Done for the part A. We found the K is equal to 5. So we move on to the part B. Find in terms of W the magnitude of the frictional force between the rod and the wall. We want to find the frictional force. So the frictional force is Fa. The frictional force is Fa. Fa is 1 over 3 Ra. 1 over 3 Ra is this. Okay. So we need to find the tension. We need to find the tension. So we can find the tension using, we already know the tension. Okay. Tension is 2 sub 3 over 3 W. Okay. So over here, from the B, okay, I mean from the from here, we will be using this. I think we will be using this formula. Using this formula will be better. Using this formula. So I will use this formula. TA cos theta plus the FA is equal to the 2W. Okay. So from A, we have a T cos theta plus the FA is equal to the 2W. We already know the T is 2 sub 13 over 3. D we already know is 2 sub 13 over 3 W. Cos theta is a 2 over sub 13. FA you do not know. Cancel this. You get FA is equal to the 2W minus the 4 over 3W. Then you get 2 over 3W. Just like that. Done. That will be the answer for the question number 4B. And moving on, we have question number 5. Okay, now we take a look at question number 5. a particle P is projected from a point O on the horizontal ground with a speed u at an angle theta above the horizontal, where tangent theta is 1/3. The particle P moves freely under gravity and passes through the point with a coordinate of 3a and 4/5a relative to the horizontal and vertical axis through O in the plane of the motion. Use the equations of trajectory to show that the u square is equal to 25 ag. So what we can do is then look for the formula booklet MM19 for the trajectory equations. So we have a trajectory equations. Telling you that the y is equal to the x tangent theta minus the gx square over the 2u square cos square theta. So we know that tangent theta is equal to 1/3. We can provide a small right angle triangle here. 1 here, 3 here, this one is a sub-tan. So at the point of 3a and 4/5a. So your y will become 4/5a. Your x is a 3a. Your tangent theta is 1/3. Your g remain as a g. X is a 3a square over the 2u square over the square. Cos square, that means it's a 3/tan square. 3/tan square, well, I think we can direct square it, make it become 9/10. Okay, no need to write square. Okay, I think we better write down as 3/10 square. Okay, so over here, we just need to be patient for a while. Simplify them first. Simplify this, you get 9ga square over the u square over 10. Okay, so you are having 2, 9, 5. You are having 5ga square uh, 5ga square over u square is equals to the 1/5a. Okay, so therefore your u square is equal to the 25ga shown. That would be the answer for the number 5a. Okay, so now we move on. At the instant when P moving horizontally, the particle Q is projected from O with a speed u and an angle alpha above the horizontal. The particle P and Q reaches the ground at the same point at the same time. Okay, so over here, that means at first, P is projected with the angle theta. Okay, so eventually P will reach over here. The x over here is the range. And the time over here, I call it t. Then when P reaches here, going horizontally, is actually the time over here is half of the time. And you start to project the Q. You start to project the Q with the angle alpha, and the Q will reach to the same time as well. Okay, so what we can do here is we will consider the B first. We don't want to make the thing so complicated over here at the moment. We consider the B first. So we want to know the R and the D. Okay, so at B, the vertical component is y equals to the u sine theta d minus a half gd square. So when y equal to 0, your d will be, you can factorize the d out. Minus a half gd. Your d not equal to 0. Therefore, your d must be equals to the, there's a u here. 2u sine theta over g. Okay, but by the way, from part A, we know that the u square is equal to 25 ag. So my u will be the 5 square root of ag. Okay, so that means the time of flight for B is actually 2 5 sub ag sine theta. What is the sine theta here? Sine theta is 1 over sub 10. It's kind of complicated over here, but if we simplify them, you should be able to get this one as a 10 A over G. You should be able to get the time for the time of flight for P. It will be square root of 10 A over G. Then what is the range? The X, if you consider the horizontal displacement, the X is actually U cos theta T. So your range will be the 5 square root of AG. Cos theta is 3 over sub 10. And your T will be square root of 10A over G. Okay, if you consider this. And if we simplify them, you can see that this 10 and 10 can cancel, the G and the G can cancel. So you will get this one as a 15A. The range is actually 15A. Okay, so now we consider the Q. Q. The horizontal displacement for the Q is V cos alpha T. Okay, and because the Q is land at the same place as P. So the Q are sharing the same range as P. But the time for the Q to reach to the ground over here is actually half of the T only. It's actually half of T only because the Q start to project when the P is halfway. Okay, so we need to divide this time. We need to divide this time over here by 2 for the Q to reach to the ground. Right here, we can just say that when the X is equal to R, then your time is a half T. Your time is a half T. So your R will be equal to the V cos alpha half of the T. The range is a 15A. So the V cos alpha half of the square root of 10A G, then your V cos alpha is actually equal to the 30A square root of G over 10A. So over here, you can just multiply it inside, everything the square root, 900A square G divided by 10A. So 90AG. That is your V cos alpha. Okay, so at Q again, if you consider the vertical component, you get a Y cube is equal to the V sine alpha E minus a half G D square. Okay, so your YQ is a 0 because when you reach back to the ground, the vertical height is a 0, and the time will be still the same half of the D. Okay, so sorry, I shouldn't say this. This one is at the D equal to the half D. The XQ is a R. I supposed to say like this. So this one also same. YQ equal to 0, your T is still the half D. So from here, you get 0 equal to the V sine alpha, half of the D minus the, okay, So this is what we have. Then if you take the simplify it, you have a half, factorize the d out, take the half d out, so you get a v sine alpha minus the d square over gd over 4. D not equal to 0. Therefore, your d must be equal to the your v sine alpha. Okay, so your v sine alpha must equal to the 1 over 4 gd. So changing your d, the d is 10 square root 10 a over g. Square root 10 a over g. Simplify it, you will get this one as the square root of 10 ag over 16. So 10 over 16 is actually 5 over 8. Now we want to find the v square. V square is equal to the v sine alpha square plus the v cos alpha square. It will be the same as the v sine alpha square is a 5 ag over 8. V cos alpha square is a 90 ag. Combine them together, you will have 725 ag over 8. That will be your v square. Okay, a bit long. So, but this is the answer. Okay, so this is the answer. You get 725 ag divided by 8. That is your v square, because the question is looking for v square. So the k is 725 over 8. So done. That will be the answer for question number 5. Moving on, we have question number 6. Okay, now let's take a look at question number 6. A particle P of mass m is attached to one end of a light inextensible string of length A. The other end of the string is attached to a fixed point O. The particle P is held with the string taut, and the strings makes an angle theta with a downward vertical through O. The particle P is projected at right angle to the string with a speed of 1 over 3 sec 10 ag, and begins to move downward along the circular path. When the string is vertical, it strikes the vertical plane. When the string is vertical, it strikes a small smooth peg. There's a small smooth peg over here. After the string strikes the peg, the particle P begins to move in a circle, vertical circle with the center A. Okay, with the center A. When the string makes an angle theta with the upward vertical through A, the string becomes slack, and the distance of A below O is 5 over 9A. Okay, so this originally the length here is A. That means then after that, this one is only 5 over 9A, which means that this will become 4 over 9A. So we have two different circles over here. One is a bigger circle. The radius is A. So we have a bigger circle. R is equal to the A. R2 is actually A minus a 5 over 9A is equal to the 4 over 9A. So you have a different radius. Okay, so I call this stage 1. And the motion at here, I call this one stage 2. Okay, stage 1 and stage 2. So we consider the stage 1 first. Stage 1 is only involving this part. Okay. Then stage 2 is involving this part. Okay. So we consider stage by stage. Now, we are having stage 1. Just write down stage 1. Using conservations of energy, we are having the GPE loss that will lead you to the KE gain. No EPE involved, so it will be mgh equal to the half m of the v square minus the u square. You will be having v square is equals to the u square plus 2gh. By the way, this one is a u. At here, this is a v. Then at here, this is the w. Okay, the speed at a different stage. So my u square is 1 over 3. So it's a 10ag over 9 plus the 2g. This one, it will be the height over here, it will be a minus the a cos theta. So it will be a minus the a cos theta. So if you simplify it, you will get this as the 28 over 9 ag minus the 2ag cos theta. That is our v square. Okay, then stage 2. Stage 2, also consider the conservations of energy again. This time you have a GPE gain equal to your KE loss. So this time it will be mgh, this one called h1, this one called h2. Then it will be half m of the v square minus the w square. So you will be having the w square is actually equal to the v square minus the 2g h2. So w square we already have here. Just copy down only. So I might need more space. So I will write my w square over here. It will be equal to the 28 over 9ag minus the 2ag cos theta, okay, minus the 2g. The height over here, it will be a plus a cos theta. Okay, a plus a cos theta. So if you simplify them, a plus a cos theta. Oh, no. This time the height, the radius will be different. The radius is no longer a. Very tricky, huh? The a is no longer a. The a is R2. R2 is 4 over 9. 4 over 9. So this one, it will be 4 over 9a plus the 4 over 9a cos theta. So this one will be tricky here. So then after that, you combine them together to get 20 over 9ag minus the 2 minus 2 minus 8 minus 2 minus 8 over 9. So you get negative 26 over 9 ag cos theta. Okay, you'll be having this. That is your second equations. Then at the point when you resolving the forces to the center, at the point that you reach over here, at this point, when you resolve the tension to this, you will get T plus the mg cos theta is equal to the mw square over the radius. The radius is a 4 over 9a. Okay, but the t is a 0. Given t equal to 0, so you have the mw square is equal to the 4 over 9 ga, 4 over 9a mg cos theta. Cancel the m, so you get w square is equal to the 4 over 9 ga cos theta. That will be your equation number 3. 2 equal to 3. That means you are having 20 over 9 ag minus a 26 over 9 ag cos theta is equal to the 4 over 9 ga cos theta. Ga cancel. Then you get 20 over 9 is equal to the 30 over 9 cos theta. Your cos theta is equal to the 2 over 3. Done. That will be the answer for the part A. Okay, number 6A done already. Then we have found the cos theta. So now we are moving to the part B. Find the ratio of the tension immediately before and immediately after it strikes the peg. Okay, so before, if you resolve the forces to the center, you will get T1 is equal minus the mg is equal to the mv square over the radius A. Okay, so your T1 minus is equal to the m over A, or what is the v square? My v square is over here. Okay, I think I go and find the v square first. Okay. Okay, never mind, since I write down already. 28 over 9 ag minus 2 ag. 28 over 9 ag minus the 2 ag cos theta plus mg. Okay, so this is the we have found the cos theta. We just put the cos theta here only. Then just use your calculator. Okay, just use your calculator. Then you will get the answer as 25 over 9 mg. That is your T1. After, also resolve the forces towards the center. You have T2 minus mg is equal to the mv square over the radius now has become 4 over 9a. Okay. So this time, you'll be doing the same thing as well. T2 is equal to the 9 over 4 m over a, the v square. I should have done the v square just now earlier, but never mind. I just copy down only. G 2 over 3, and then plus the mg. So that's a matter of pressing the calculator. Then you can see that multiply the press the calculator, simplify everything. Then you can get this answer as 5 mg. That is your T2. Okay, so the ratio, they want the ratio between before and after. So it will be T1 divided T2, 25 over 9 mg divided by 5 mg. Then you will get 5 over 9. Therefore, the ratio T1 before and T2 after is the same as a 5 to 9. Done. That will be the answer for the question number 6. And moving on, we have question number 7. The of mass mkg is held at rest at the point O and released so that it moves vertically under gravity against the resistant force of magnitude 0.1 mv square, where the v meter per second is the velocity of p at time t second. Express v in terms of t. So over here, if you're going vertically, you will be having the F is equal to the weight mg minus the resistance force 0.1 mv square. Make the F become ma. So this is what we have. Cancel all the m. You get your A as a G minus a 0.1 V square. So usually the 0.1, I will make it become 1 over 10 V square. Okay. And I think the G, I also make it become 10. The A over here is, we can choose either dv dt, or we can make it become v dv dx. But since they want v in terms of t, that means we have only one choice. The A must be equal to dv dt. So we will choose our A as dv dt. Using the separable variables, combine them together, you get 10 over the 100 minus a v squared dv is equals to integrate dt. Well, you can use the formula booklet MM19 to integrate directly, or you can use partial fractions to expand them. So over here, I will use partial fractions. I will get this one as the 10 plus b. This one is 10 minus b. I will use partial fraction to split them. This one will be d plus c. And when I integrate them, I get this one as a ln modulus of 10 plus v minus the ln modulus of 10 minus v equal to d plus c. Combine them together, you will have something like this. I need to find a constant c. To find a constant c, we need initial value. So the initial value is starting from rest. When t equal to 0, v equal to 0. That will give you the c is equal to the half ln 1, which is a 0. So that means the equation right now, it will go like this. So if you were going to get modulus of 10 over 10 plus v over 10 minus v is equals to the e power 2t. Okay, so when we take away the modulus, there are two possibilities. Either we need to put positive, negative. We need to choose one of it. So the answer here, it need to fulfill t equal to 0, v equal to 0. And in order to fulfill that, your answer must be positive. Okay, so just mention like this will do. Just straight away take away the modulus, you decide it to be positive e power 2t. So therefore, because of the reason of t equal to 0, v equal to 0. Okay. Now, we cannot leave the answer like this because we want the answer in terms of v, in terms of t, v in terms of t. So we have 10 plus v equal to the 10 e power 2t minus a v e power 2t. So we have a v of 1 plus e power 2t equal to the 10 of e power 2t minus 1. Then you will have the answer v is equal to 10 of e power 2t minus 1 over the e power 2t plus 1. That will be the answer for the question number 7a. Okay, done. Then now we move on again. Now they want you to find the displacement. Oh, sorry, they want you to express v squared in terms of x. Okay, so they are talking about displacement already. So remember just now I mentioned that when you are having A, you have two options. Okay, when we are having A here, we're having two options. A can be dv dt. A also can be v dv dx. So now for the question B, we need to change our A to become v dv dx. Straight away copy from the relationship here. Just make the A become v dv dx. So it's a 10 minus 1 over 10 v squared. So this time it will be 10, I combine them, become one fraction that will be better, 100 minus v squared over 10. Okay, so 100 minus a v squared over 10. So I have 10v over the 100 minus the v squared dv equals to integrate dx. So I will be using the formulas of f prime, integrate f prime over f. in order to integrate the formula for the left-hand side. So this answer will be 5 ln modulus of 100 minus a v square equal to the x plus c. Okay, so when x equal to 0, your v is equal to 0 based on the information given in the questions. So we have c is equal to negative 5 ln 100. Okay, maybe I shouldn't call c, I should call it d, because c just now part A we already used c, so this one I call d. So now we are having negative 5 ln 100 minus the modulus of v, 100 minus v square is x minus the 5 ln of 100. The 100 is already positive, no need to put modulus. So join together, your x will be equal to the 5 of ln 100 divided by 100 minus a v square. So your 100 divided by 100 minus a v square is equals to the e power of 1 over 5x. Take away the modulus. We need to decide this one is plus or minus. So because of the reason x equal to 0, your v is equal to 0. Okay, then therefore you need to choose the plus. Okay, it's a positive. So now the remaining part will be quite easy. 100 minus a v square is equal to the 100 e power negative 1 over 5x. So the v square is equal to the 100 of 1 minus e power negative 1 over 5x. Done. That will be the answer for the question number 7b. And this is the last questions for this paper. So I will stop the video here. I'll see you next time. Bye-bye.